Assalamualaikum. My name is Muhammad Farhanuddin bin Fazil. Our group will present our project report titled Slope Remedial Techniques, Slope Stability. We are from Group C. Below show our group member. First, Muhammad Izzat Azim. Second, Umar Rizwan. Third, Muhammad Shazwan Ramli. Fourth, Muhammad Farhanuddin is me. Fifth, Muhammad Nabil Farhan. Okay, for introduction of our project, Slope Failure. Bukit Antarabangsa Hulu Klang Selangor is a hilly terrace with elevation ranging from 133 to 203 meter above sea level. Furthermore, due to the unstable slope condition, a number of earth material as well as some of the house of the resident involved collapsed along the slope and were piled to a few hundreds meter from their original location. There are various classification of slope failure, but the most useful are those that use the type of movement and the type of slope forming material involved as a primary criteria, with velocity and amount and pace of water as secondary consideration. Okay. Next is type of failure. First, falls. Falls are rapid downward movement that are not preceded by any initial movement or warnings. They happen when a rocky mass separates from a slope along with a discontinuity plane, which can be associated with fracture, joint, and bedding. The type of movement can be free fall, bouncing, rolling, or a combination of these. Next is topple. Topple are also failures that occur in rocky materials and resemble falls. Topples are controlled by a combined action of gravitational forces that include a bending movement and external forces. Example, weathering, water pressure, freeze-thaw cycle. Okay, next slide. Slide refer to a ground movement along a specified surface or zone of weakness. There are two main types of slide, rotational and translational slide. A rotational slide will eventually stop propagating as a stress equilibrium is restored with the mass movement. As an example of a rotational slide is shown below. Next is lateral spread. Lateral spreads are deformational phenomena caused by liquefaction, the process during which a saturated soil, usually sand, experiences loss of strength after a sudden change in its initial stress condition. Lateral spreading is usually a progressive process that occurs mainly near shore, riverbank, and port where loose and saturated sandy soil exists. Next is flow. First, the debris flow. Debris flow are usually triggered after heavy precipitation saturates and mobilizes the soil, or they can be caused by another type of landslide upwards. Second, debris avalanche. A rapid debris flow frequently triggered in steep slopes when the material cohesion is relatively low and when the water content is high. Earth flow. Flow in fine-grained soil or clayey rock under saturated condition. Next, mud flow. A rapid flow consisting of at least 50% clay, silt, and sand particle. They are categorized by a high water content, and sometimes they can refer to as mudslides. Last, creeps, a subtle and steady type of downward flow caused by shear deformation. Shear stresses are high enough to cause displacement but not adequate to result in shear failure. Okay, next is engineering practice in slope stability. In practice, an engineer must always ensure the stability of a slope given the worst case scenario. An optional design also accounts for the financial feasibility of an engineering project. Thus, the objective of applying support measure is to increase the FOS with the minimum required and/or available resources. Hence, the selection of the most appropriate support measure is a case-specific issue. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzat Azim bin Hazrin. So for literature review, I'm going to discuss about technique of slope stability. So for the first for the first technique, we have soil nailing. Soil nailing technique used to reinforce soil to make it more stable. Soil is reinforced with slender elements such as reinforcing bars, which are called as nails. These reinforcing bars are installed into pre-drill holes and then grouted. So this diagram shows how soil nailing works on construction site. Then for the second technique, we have shotcrete. So what is shotcrete? Shotcrete is a term used for concrete and mortar conveyed through a hose pipe and spray at high velocity onto the surface. As it projected from the nozzle, shotcrete undergoes both placement and compaction at the same time. Shotcrete can be produced by either dry mix or wet mix method. So this is how shotcrete is implemented in construction site. Third, we have vegetation. Vegetation stabilizes slope by providing roots strength and by altering the saturation regime of soil water. Within a weak soil mass, root can be penetrate fracture in bedrock, can cross zone of weakness to more stable soil, and can provide interlocking long fibrous binders. So basically, they use plant to give strength to the soil because the root can hold the soil so it won't become weaker. And lastly, we have geometrical method. The changing of the slope angle from steep slope to a gentler slope may increase the stabilization of slope, and the angle is usually supported by grass bonding together with soil. This method is usually simple and less costly. Basically, this method is commonly used in residential area because this is a conventional method, and as I just mentioned, uh, is this is the most cheap method from the other trees. So that's all from me. Thank you so much.
Hello, my name is Umar Rizwan bin Umar Razi. My metric number is CF190216. So today I will explain about proposed technique of slope stability. So the technique that we propose is soil nailing. The soil nailing techniques was developed in the early 1960, and it was first used to reinforce the ground with steel bar and the shotcrete. Soil nail can be used to stabilize and straighten slope or structure that are deteriorating or unstable. Soil nail develop their own reinforcing action through soil nail interaction based on the ground deformation, which is used to bring soil stability and retain the soil in order to prevent any collapse. In terms of construction cost, construction time, and technical feasibility, soil nailing is a viable alternative. Soil nailing advantage. Firstly, it's cost effective. Next is effect less disruption toward traffic. Then is low environmental effect compared to other technique. Then relatively flexible and can accommodate a large total and different settlement. Lastly is can adjust the location of nail, length and inclination when obstruction encounter. Design consideration of soil nailing. The analysis of the site is the first step in the design process. The most common limit state used in a design are strength limit and service limit state. For the third is height and length, and fourth is vertical and horizontal spacing of the soil nail. Next is ground properties. Six is nail length and diameter. 7 is drainage, frost and frost penetration, and lastly is external load due to the wind and hydrostatic force. For the type of soil nailing technique, firstly is grafted soil nailing. This method of soil nailing uses a pre-drilled hole in the wall or slope face, which are then filled with nail. The hole is then filled with grafted materials such as concrete or shotcrete. A nail diameter range of 100 until 200 mm was installed with a 1.5 meter spacing. Secondly is driven soil nailing. This method is used for temporary soil slope stabilization and is considered a fast technique. It does not protect the reinforcement steel or nail from corrosion. The nails are driven into the slope face during excavation in this method. The nail diameter is 19 mm to 25 mm, which is smaller, and the nail spacing is 1 meter to 1.2 meter. Okay, lastly is the jet grotted nailing. Jets are used to create a hole in the slope surface when eroding soil. After that, compressed air is used to force steel bar into the soil at high speed, and the area is then routed with concrete. This technique improves the corrosion resistance of steel bar and also known as nails. That's all for me. Thank you.
Assalamualaikum. My name is Muhammad Nabil Farhan bin Muhammad Nasir, and my matrix number is CF190230, and I will present about the application of soil nailing technology for strengthening the dam under hydroelectric power station. The historical hydroelectric power station in Rupki, located 20 km west of Gas, was erected in 1910 on the Radunia River. A 12-meter high dam blocks the water flow of the river, which has an alpine character and a swift current. A 5-meter high concrete retaining wall supports the dam toe. As you can see, this is a picture of concrete retaining wall. And the wall needed to be repaired right away to avoid the structure from failing due to the long-term degradation. The use of soil nailing technique allowed this old retaining wall to be rebuilt and the dam base to be strengthened without having demolished it. The stone facing was removed in the first stage of wall restoration, after which a layer of light steel mesh was applied to the wall and 70 mm thickness of the concrete was sprayed. Following that, 1.3 meter vertical and horizontal nail holes were drilled through the structure. After that, high-yield steel rod with the diameter of 16 mm and length of 5 meter were put and grouted into the boreholes. Finally, the stabilized wall was finished with the stone facing. And this picture of stone facing was applied as a finish to be stabilized wall. Thank you.
Hi, my name is Muhammad Shazan bin Muhammad Ramli. My matrix number is CF190222. Today I want to present long-term stability analysis. A slope stability analysis based on the two dimensional limit equilibrium method was done to evaluate and analyze the performance of both stabilization technique discussed above. Second, the force of our movement preventing mass movement or the compared to those that can produce unstable motion in this manner. And the third, the circular shape of slip surface and the rotational movement on the projective slip surface and the soil mass are taken into account. Three examples of stability of the Bukit Antarabangsa slope were included in the analysis. The slope before stabilization, second one, the slope stability with a piling system, and the last one, the slope stability with the soil nailing. Okay, we can see the figure. So the figure 1, slope stability before stabilization, and the second one, slope stability with piling, and the last one, slope stability with the nailing system. Okay, that's all for me. Thank you.
For the conclusion, first, reinforced soil allowed for the stabilization of existing historical structure without the need for rebuilding, which save money while maintaining serviceability. Next, an economic analysis of Bukit Antarabangsa in Ampang as well as other soil nailing structure show that this technology save approximately 30% of the cost of traditional method. It is one of the most effective slope stabilizing methods. It is also worth mentioning the ease of use, dependability, lack of vibration, and low noise level while nailing. Last, it is important to note that when using this method, architectural features are usually unaffected by soil nail because they can be placed to pass around or between obstacles. That's all for our conclusion. Thank you.